Hello, Traveling Machinist here. Alright, today we have a video for you that is highlighting a company over in New Ulm, Minnesota. And the company name is DLC, Donner Laser Company. I've known DLC for many years now. I've worked with Brent over there for doing my clutch plates and my tower machine goods, open belt primaries back in the day. And he cut out all my clutch plates and all my clutch cores for the fibers. And you know, he just put up a new building here a couple of years ago. He's got 8 Trumpf CNC lasers that go up to 6,000 watts. So without further ado, I will get into the video. Enjoy. Alright, this is the second drone footage I took from a higher altitude. And I'm just wondering which one you guys prefer. The first one that you just saw or this one? Put down in the comments below which drone footage looks a little better. I think this one looks really good because it gets the whole lot of the place. That building that they're erecting right there, that's going to be, if you see the steel out on the front side of the building there, those are skeletons. Those are going to be housed underneath this building they're putting up now, so that it keeps the rain and snow off of the steel, and then they'll house it until they get it to the scrapyard. Way to go, DLC, for being sustainable. Hello, Traveling Machinist here. I'm over here in New Ulm, Minnesota, checking out DLC. This is a laser company that has 8 lasers. Trumpf is the manufacturer of all the lasers in-house. I'll take you for a tour. Let's go for a walk. I'll turn you around. So this building's about 4 years old. I've known Brent, the owner, for many years. Back in the day, he did laser cutting for some of my clutch plates, my clutch cores, I should call them, and also some steels. So we did a lot of clutch housings, but this is his new building he put up about 4 years ago. And we got music going on inside, so not going to be able to go in there right at the moment. Let's take a walk around the building. They're putting up an addition over there. Got the airport next to us. Beautiful building. He's got one press brake inside. Take a walk here. So let's enter into DLC, Donner Laser Company. These are resonators made into coffee tables. I don't know a whole lot about resonators, how they work, things like that, but this generates the laser beam. ISO 9001 certified. Some articles. All right, let's take you to the shop floor. Very clean, perfect little space. I believe there's 8 workers here. What they do here in this little shed back here, it's going to get a little noisy. How you doing, sir?
Pretty good.
So back in this little shed here, is they generate their own nitrogen. The nitrogen is used as a shielding gas. So it might be a little noisy in here, so I'll try to talk up a little bit, but the air is made up of like 70% nitrogen. So what they're doing is they're just compressing and cleaning just the nitrogen out. This nitrogen is, I'll come out of here. Nitrogen is inert gas, so it's not flammable. And what it does is it keeps the oxygen away from the cutting of the laser itself. When the metal gets molten, just like in welding, if you have oxygen, it creates bubbles and problems. So this here is a fiber machine.
Like when Aaron Jones is healthy, he doesn't get the ball or he's in there, very sparingly. And then on defense, it's just the same shit.
It looks like they're working on
Yesterday I do.
some stainless in this one. This is a 6,000 watt. And as you can see, these are some of the parts he's making. And then that's what's left. What kind of material is this?
1/4 inch stainless.
Stainless? That's what I thought. So that would be a skeleton. That's what's left, which will be scrapped. And they can cut any shape that you want. I believe the 6,000 watt machines will do up to 1.5 inch steel. Yeah, 1, 2, 3, 4, 5, 6. Yeah, 8 lasers in here. See if this one's running. Oh, he's changing his sheet. Brent is also a technician. Here's what the sheet would look like after it's cut. See if we can take a look inside here. We're cutting 1/2 inch material here. You can kind of see how they have specialized software to nest the parts onto the sheet to maximize material. Very impressive. Now, when I said a fiber machine before, the laser beam actually goes down a fiber optic cable and then gets out to the head and to the steel. But in this older, well, I don't know how old this machine is. It looks brand new to me. But you can see right up here in this corner, right in that edge, there's that aluminum. Basically, there's mirrors in there. So instead of having a fiber optic cable transmitting the laser beam, it actually bounces the laser off of those mirrors and then down to the head. And there's some restrictions with that. I'm not an expert at all this, so that's best Brent's department. And here you got a chiller cooling down the resonator like a radiator. And then this system here sucks in cold air from outside and then pumps it right back outside so that it doesn't get so hot in here. Pretty impressive stuff. He's got a couple of machines here he's rebuilding, because Brent is a technician for these, or consultant, let's call him, but he's like goes out on the road and fixes these machines. So he does know how to fix them all and get them back up and running to 100%. So he's got a couple of machines here he's putting back together or working on. In some cases, these are smaller tanks of nitrogen. Not sure if he uses them for specialty items. But I met Brent a long time ago, like I said. The press brake over here. Super clean shop. Let's head over and meet Brent. There's the man himself right there. How you doing, boss?
Good, how are you doing? Pouring slabs out.
Imagine that, a boss actually working at his company.
All I do.
He cuts his own, what do you call these, grates?
Slabs.
Slats.
Make their own slabs. Got a laser, why
Yeah,
wouldn't
why
you,
wouldn't
right?
you, yeah.
Right. A lot of people don't buy them in. I don't get that, you know?
Time on the machine, maybe?
Yeah, usually.
So you're an expert technician also.
I don't know if I call myself that, but
Well, that's not what I heard.
I like to take care, that's for sure.
We're using suction here to lift the sheet up, which is pretty impressive.
Yeah, it's the best way of doing it. Magnets. Make them much go. That way we can do stainless, aluminum, all that.
Gotcha.
You just use magnets and you can't do it.
The other way to move a sheet like this would be to use a magnetic type of lifting mechanism. But what he's saying is that if he's doing aluminum sheets or stainless, they're non-magnetic, so the magnet wouldn't help those sheets. So suction is the way to go. And it looks like you can lift 4,000 pounds on this thing.
Yeah, our biggest sheet is inch and a half. Weighs about 4,000 pounds. That's why we have them all set for that.
Okay. And I gotta get out of the way.
Yeah, don't let me run you over.
So how many 6,000 watt machines do you have?
We have three.
Three?
6,000, 2 5,000 watt CO2s, one 5,000 watt fiber, and then this old girl is 4,000 watts.
Okay.
This is the oldest machine in the shop. The last one I just bought. Yep. Okay.
So the fiber, what's that?
You just have to be behind that light curtain.
Gotcha.
You can be anywhere you want, just behind it.
What he's talking about here are these yellow posts. One here, one over there. It shoots a beam of light around the table so that if I'm in that light beam, it'll shut down and it will not operate. This is how it transfers the sheet in. There's a table that comes underneath. And then the new one goes in. As you can see, the sheet that came out is completed.
Doing a sheet measure now, so it squares the sheet up.
Okay.
If you want to catch that from the beginning, or you just want to?
Yeah, we could. Yeah. Okay, so what he's gonna do here is he lined up the sheet on the markers, the little tabs on the corner here.
Yeah, now the head's gonna square. It's gonna check it there, and then the location.
Yeah, it's moving faster than I can.
Yep. Then it's gonna square the sheet out to the program, so you can't go off the sheet.
So basically, it's like orientating
Yeah.
the sheet, even if it's not 100% square to the guide. It'll compensate in the software and put the sheet at an angle, so that way the parts don't get off the sheet.
If you look at it when it pierces, you see how it sprays all the way around. That's how you know your centering is on. Like the nozzle is centered.
Oh, I see what you're saying.
If it just sprays to the right, it's off. The centering's off. Oh, it lost its 0.0. It's too far back. It's just too far off. Now it's got to do it all over again. See if it's too far forward, then it runs into a software limit. I was too far this way. See, we put all new slats in it because we bought this from Monica, Georgia. And see how low their slats would have been? Their slats would have been way down here. So we cut ours a ½ inch to 1 inch higher. So you never Z-fault out. Meaning you never, if the sheet gets too low, the actual Z itself will fault out. Because it's too low.
Because of travel.
We raise our slats up and then we never ever have Z-fault problems ever because our slats are too high. You know, anybody that has a laser, if they raise their slats up a ½ inch to 1 inch, they'll never Z-fault ever. So all of our slats here, see now, because of that, I had it too far forward, it was going to go to its software limit.
And what you're talking about is they're raising the sheet up off the table so that the head motion does not over travel in the negative Z direction.
And most people don't do that.
Compared to like a flame torch, this will give a way precise cut, and it has very little curve, even on larger parts, even though there is some curve. Because they do make tables that use oxyacetylene torch type system to cut through. But with the higher wattage machines nowadays, it's amazing that they can cut through 1.5 inch, 2 inch, and even beyond that. It's all being done with a light beam. And I'm no expert at lasers by any means. I call myself Traveling Machinist, not because I've worked on lasers. There's the first part done. Alright, Traveling Machinist here. Donner, Brent Donner's educating me on what gases are being used for what, and I'll let him do a little more explanation of it. Okay, Brent, you have that shed over there with the nitrogen generator, correct? Yep. Get you on camera here.
Okay.
That is mainly used for shielding gas and also purging gas.
Yes, beam purge on the CO2s and then cutting gas on any machine that's.
So what do you mean? What do you mean CO2? What is that?
So like the CO2s have beam delivery optics. Like let's call this machine for instance. This has 8 beam delivery optics that bring the beam to the cutting head. Okay. The fiber laser has a fiber optic cable. That's how the beam is delivered, but it uses the cutting gas of nitrogen or oxygen on that machine. There's no other gases that are purged in that machine. The CO2 is different because you got CO2, helium, and nitrogen that are all mixed in a gas mixture to generate the beam of light. When the beam of light comes out, it goes through 8 optics to get to the cutting head, and the bellows have to be purged with nitrogen so the beam doesn't start to walk and move on it. You know, older machines had compressed air in them, and as you got a better quality of nitrogen or a lesser quality, the beam would expand and contract. And Trumpf came up with this back in the 90s that if they purged their beam delivery system with nitrogen, the beam stayed tight.
Okay, so you do not use oxygen.
We do that for cutting gas as well. So we use that system.
Does that not like a torch in a way? I mean,
yeah.
So or like right welding, now, oxygen.
Yeah.
Oxygen is bad for welding.
You got mild steel, and we use a lot of oxygen to cut our mild steel. But if the customer says, I want 7 gauge with an oxide free edge, then we cut with nitrogen. But you would take, like, say this 4,000 watts, you're gonna run it on 7 gauge about 160 inches a minute, okay? Now the customer says, I want that same 7 gauge cut out with nitrogen so the oxide isn't there. You're gonna be running that same material at about 80 inches a minute, maybe even 90 on a 4,000 watt laser. But you're gonna get a super clean edge, no oxide on it. It's instant weldability without worrying about that oxide on with the oxygen.
Okay.
Okay.
So it does oxidize the edge using oxygen as a shielding gas.
Yes. But like for this machine can cut 1.25 inches. Started cutting 1.25 inches on one of these back in 1998. The 5,000 watt will cut 1.25 inches. You can't get thicker than that. Once we get to the 6,000 watt, then we can cut 1.5 inches, and I've actually cut 2 inch on my 6K. I can't get over 1.25 inches on a 4K or a 5. There's just not enough power. You need that 6,000 watts to even get remotely close to cut 1.5 inches.
Okay.
You know, but you were asking about that gas in there. That is used primarily for the fiber laser for cutting gas, and then it purges the CO2 over there for beam delivery and this machine. These are the only 3 machines that system runs off of for purging, and then it can cut every laser. All 8 of these machines can cut with nitrogen on them with that system. You know, but now here, this is what I was talking about. You got your CO2 and your nitrogen and your helium. Okay. These 3 gases get mixed in the gas mixer over here. I don't have a key to open it up, but they get mixed in there, sent to the resonator, and the exciter is the CO2. That's why it's called the CO2 resonator, because that gets excited and it generates the beam because of that CO2. These are just all mixed together, pre-mixed station on the mixer, and then it goes into the resonator. It gets hit. This has a 22,000 kilowatt generator, and right now to get 4,000 watts, it's pushing 19,000 kilowatts. The electrodes on the resonator get hit with the electricity, and the gas gets excited and generates a beam of light. It's pretty cool stuff.
It is cool.
Yeah.
Now, what kind of? I see you got only 3 tanks here for this.
Yep.
How long would this last?
These will last about a month, and these will last about 2 months, and these have been lasting us about 6 to 8 years.
Really?
So every laser is leak tested here. Most people just throw the bottle on, they don't give a crap about it. Not us. Like, everything is leak tested, so where somebody's burning through one of these in a week or 2 weeks, we're burning through 1 month, month and a half. Depends on what we're cutting and how hard we're cutting on the machine. And then this is used, what is it? This is a month and this is 2 months, but this one can go for years. So that's full of liquid. You know, so a lot of places I go into when I'm consulting, they're burning through gases left and right, and they find out that they're leaking either from here or connection at the gas mixer, and nobody ever pays attention to it. But
So,
we leave see these are on?
Yep.
These are left on 24/7. Everybody that shuts these off every single night, they're just burning through gas. It gets up in, this hose is good, but helium is so light, it starts to dissipate out when it starts to drop pressure down. If you keep these open all the time, it keeps the positive pressure and none of the molecules ever come out. But most people don't do that either. They shut these off every night. You know, I was taught back in the day,
it's
you
common
turn
sense.
1, 2, 3 on, and then 3, 2, 1 off. Nah, that's all crock and crap. You know what I wanted to say. But we leave ours on. Every CO2, you know, we have 7 CO2s in one pipe. Like I was explaining to you, we get way more work off of our CO2s than we ever will our fiber, because our wheelhouse is 1/2 inch to 1.5 inch. That's what we cut.
Okay.
Fibers are good, but the cut quality is, to me and to our customers, is horse crap. I was going to say it again. That's why we have all the CO2. And when we do build the expansion, I'll have, that building will be full of CO2s. The only fiber we'll have is the one that we have. We'll never own another fiber, because
Okay.
everybody else is going to fiber. So,
All right.
crazy stuff, huh?
Thank you.
Yeah.
Thank you, everyone, for watching my video. Please hit the like and subscribe button and hit that bell notification. Thank you. Enjoy and be kind.